Hey guys, in this video we will deploy the VG16 model that was trained on FIR 2013 dataset for inference. First, we're going to do a quick recap of what was done last video. So in the last video, we basically coded VG16 from the scratch and trained it on FIR 2013 by PyTorch Lightning. We started with data processing, where we load the data from CSV file, created a custom dataset class, and then load it into train loader, validation loader, and test loader. We also look at the structure of the original VG16 model and coded this model from scratch using PyTorch Lightning. This model was trained on PyTorch Lightning for 150 epochs, and now we have a checkpoint path and we are ready to use the model for inference tasks. Let me rerun all these block of code. So here I will probably interrupt the training here because I already trained it before and already obtained the checkpoint path. So in this video we are going to deploy the model that we trained for inference. But first let's load the model from the checkpoint path. On your computer you can call the checkpoint path from trainer.checkpoint callback best model path, and here I have the checkpoint which is trained on Google Colab, so I copy this path into my personal computer. By the way, this inference is run on a MacBook M1 CPU. So first we load the model from the checkpoint path and we do some inference on the test set. Now the evaluation is done and we can see that the accuracy that we obtained on the test set is 71.57%. Next, I would like to list out the 7 emotions that were used in FIR 2013. So here we have angry, disgust, fear, happy, sad, surprise, neutral. For each of these emotions, I also list out the color for the rectangular box that is going to be drawn, and also color for the text that is going to be drawn later. Our first inference will be on images. To do inference on image, we will apply 2 main steps. First, we use the API face recognition to extract facial regions in an image. And after that, we use the model to classify emotion from these extracted regions. So here, we need to import OpenCV and import face recognition. I will define a function which make inference on image. So this function take in the model and the image, and note that here image is an OpenCV image, not the path to the image. So first we put the model to evaluation mode, and here because we are using the model for inference, we don't want to keep track of the gradient, so let's put a context touch no grad so that we don't keep track of the gradient. First we extract all the location for faces in the image. That is done via face recognition dot face location. So each of these locations come in the form of 4 coordinates which indicate the top, the right, the bottom, and the left of the facial regions. So here we will extract the facial region from top to bottom and left to right. We will convert our image to grayscale. We can note that our model take in image as grayscale image. So let's say face gray, convert to color. So we have BGR to gray. So note that in terms of shape of the image, the original image, the original face has image has shape WH3, and once we converted this to grayscale, this is W by H. Because our model take in the data with shape 48 by 48, we will also resize the facial region to shape 48 by 48. So at this point, the facial region has shape 48 by 48. In order to do the inference, we will transform each of the 48 by 48 image into 10 sub-image, and our inference will be the average of these 10 sub-image. Note that these 10 sub-image are the crop of the original image with size 44 by 44. So after we do the transform test, we will have 10 sub-image of size 44 by 44. And now we do the predictions. We apply the model to do the prediction. Note that in this case we have 10 sub-image and there are 7 emotions. So there are 7 logits which indicate the probabilities for the 7 emotion. Our prediction will be the mean of these 10 sub-image. After this we only have 7 logits. To get the index of the emotion, we will apply the argmax function. Well, now all that remains is to draw a rectangular region and put text. So here we will draw a rectangle on the facial region first. So the rectangle is from top left to bottom right. And we also draw another rectangle, so we have some basically some part to put in the text for the emotion. So this is to create a region so we can put in the text. Now we will put in the text. I will use an F string here. So the name of the text is the first index, as you can see from here. Angry, disgust, fear, happy, sad, surprise, and neutral. And then these are just some region for putting in, for writing the text. Alright, well, at this point we will return the image. You can also write the image here to a file, but I prefer not to do so. because later I would use this function to do inference on video. So I only want the array that was POSIX. Alright, so now let's run these functions. Invalid syntax, it should be image from array. Now we will do inference on an image. Well, first let's load an image from my computer. If you have an image, you can use your own image. Maybe it's a good idea to show you the image. So the image that I'm going to use for inference look like this. There are a lot of people in this image, and they may show different emotions. So let's first load the image using CV2. Here I will do inference on this image, and I will write the inference image into a file. I want to put this in the inference folder on my computer. Well, emotions. Let's check. So here is a image that I just do inference. You can see that in this image we have different emotions like happy, angry, sad, surprised, and so on. Well, they look pretty much reasonable here, except for some classification where it show angry. I think the reason here is because, for example, for this gentleman, because he show a lot of this, usually in our training set, when there are a lot of this, that means somebody is angry. There are a few cases where the model doesn't even recognize the facial region. For example, for this lady, because her face is partially occluded, it doesn't recognize her face. And this lady and this guy. This is due to the face recognition API. But in general, this is quite reasonable. That is inference on image. Next, we'll do inference on video. To do inference on video, we simply read the video and then do inference on every frame. And after that, put all the frames together to create a new video. So here, inference video, auto and path. Here, path is the path to the video. First, we will extract the video features. First, we need to read the video. I want to extract the width and the height of the video. The height will be cap.get4. And I also want to have the FPS of the video, because later when I rewrite the frame into a new video, I want to choose the exact FPS. Number of frames. Frame count. Okay. Let's create a codec to write new video. Here I use video writer to write an MP4 video. Well, in our original video path, it will be ended with .mp4. So here I will take out the .mp4. For the name of the new video, I would add out mp4. and then we have the codec to write MP4 video. I'm going to use the same FPS, same width and height for the same width and height for the output video. Alright, so now we are ready to read frame by frame, make inference on this frame, and drive into a video. We will read the frame continuously. Success image. If the reading is successful, we will do inference on the image frame. The inference here take in model and image, and then we will write the image into a videos. If we cannot read, then we will break, and finally we will release the video. And CV2 destroy all Windows. All right. Well, one thing that I like to do when I process video is I want to put back the original audio. So in this function, we only just stack all the frames together and we lose the audio of the original video. So here I would like to put back the original audio into the new video. To do this, I will need movie py and import from movie py editor. So here I'm going to combine video and audio. Well, the path here should be the path of original video clip. First, we are going to get the process path. The process path in this case is the path of the new video that has no audio. So this part was the one that we do in the function above. So that is part of blast out.mp4. Well, we will extract the clip from process path using a video file clip. We will extract audio file from the original clip. So audio. So here we take in the original path and we extract the audio. So now we have the clip and the audio. We will set audio for the clip. Use clip dot set audio. And we will finally put a new file name and write a new video with audio. So the new name will be we will take out the .mp4 and we will add maybe with audio out.mp4. And now we will write them into a video new name. The codec we use is libx264. All right. Well, so now let's put them together and do inference. So here I want to time to see how long it takes to do inference on a simple video. Well, you can load any video on your computer, but my suggestion is do not have a very long video. Here the video that I use is a debate between Elon Musk and Jack Ma, I think in 2015 or something, about AI. So just to print something to say that it is doing the conversion. Let's time the start. First we do the inference, and after inference we also combine the video with audio. And then print the time that is used to do the conversion. End time minus start time. So here let's print out the minutes. Well, I also want to print out how many frames are there for this video. So let me just copy the code here for the number of frames. Just to see how many frames we need to process. Cap 2, print frames, frames. All right, so we are ready to do it. Well, our video has 888 frames. It will take time to process all these 888 frames that correspond to 888 image. While we are running inference on video here, let's now write the code for running inference on live camera. Well, first I want to write a function that gives just prediction for emotion on a single face. Right? Here, let's put the context managers to not keep track of the gradient. So a touch, no flat. So this function is going to give prediction on just one single face image. Face here is a face image. We put the model to evaluation mode. So first we need to convert to the face image to grayscale and resize it to the size 48 by 48, which is the size of our data for 2013. CP2 convert to color. So the color here is from BGR to gray. And then we resize to size 48 by 48. So here we will put the data type to be UNIT8. So we know that in order to do inference, we need to randomly crop the image, the face image, into 10 sub-image and do inference as average over these 10 sub-image. So the input to our model will be 10 sub-image. The transform test here is a random cropping of the face image into 10 sub-image. So at this point, the input in our model have shape 10, 1, 44 by 44. Each of the sub-image is a grayscale image, so it has one channel. All right. Let me come back to this later, but for the time being, let me finish this function first. Our prediction will be model input. So here the output are shaped 10 by 7, and to get the final prediction, we need to get the mean that gives us the probabilities for the 7 emotions, and our prediction will be the argmax. Well, let's go back to what we did here and see why we have this error. Movie PY editor has no attribute video clip file that was in audio. It should be movie file clip. All right. Well, at this point, we have already done the function, this function here, and the function that gives error is the combine functions. Unfortunately, we put them together, and the time here was not timed because of the problem in the combine functions. So here I will run it again, and while we are running, we would keep writing the inference on live camera. Well, so now we are ready to do live inference. First, we will load our webcam. I only have one camera, that is my computer webcam at index 0. Well, for faster inference speed, I will only process every 2 frames. So process this frame, we will set to 2. So we only process every second frame for faster inference speed. And here I'm using CPU on MacBook M1. We will read the frame, process it, and then display it. Success frame. If process this frame, so here I will do a trick, that is to resize the frame 4 times so that we can run the face recognition faster. Resize 1/4 of original frame for faster inference. I will call small frame. So we will resize original frame. By 1/4 on both the width and the height. Well, the face location here will be obtained from face recognition. So I noticed that by doing this, it speed up considerably, and it makes the inference look quite smooth in the live camera. So here we only want to process every second frame. So after we process one frame, we will turn off the indicator setting process this frame to not process this frame. So now we will use the face location. We will extract the facial regions and give prediction and display the result. Give predictions to facial regions and display the result. So each of the face region is a tuple of 4 coordinates: top, right, bottom, left. So the face region here is from top to bottom, left to right. And now I will use the prediction function that we write on top here to give prediction for the emotion of this facial region. And after we get the emotion, the classification of emotion for the facial regions, we want to scale back up face location to draw boxes later. Top, right, bottom, left, they are all scaled up 4 times. And the final step will be to draw rectangle and put text around the faces. So here are just some routine to draw rectangle and put text. We will draw basically 2 overlapping rectangles so that we have some region to put the text. And then we will put the text. Well, so here I should use an F string for the text. For the text size, I put 1.5. So we have finished writing the code for inference on live webcam. In the meantime, the inference on video is also finished. So the total inference time for this video of 900 frames is about 6 minutes. So here, not only we do the inference on the frames and put them together, we also combine with the original audio. Let's look at the result. So this is the one with audio, and this is the one without audio. So maybe I will open the one with audio.